All right, so if you did not watch last time's video, because I know a lot of this class was testing, I'm going to do my best to kind of just bring you into what we did last time without going backwards. So we're going to start on this question. Can you find it? Yeah. Okay, so we did the first half of the notes last time. Okay, hopefully you watched them. If not, you might be a little bit lost, but like I said, I'll try to catch you up. And then Alon, once you're in the total registration, you can go to Mr. Strohmeyer. Okay. All right, so first thing, implicit differentiation is when you're taking the derivative. Here they are. Good. Okay, of x's and y's that are kind of all jumbled together. So if I'm taking the derivative for number 9, you need a pencil, honey? Right there in that little gold cup. There are at least pens. This is last time's notes. Almost. Remember. All right, let's take a seat. Let's lock in. Okay, so when you take the derivative of this term, it has x's and y's. You need product rule. Do you remember? Yes. Okay, so put PR, underline your pieces. So you have an x cubed multiplied by a y. So I'm going to put it maybe over here to the side. My u is an x cubed. My v is a y. What would that make my u prime? If you were here last time, help us out. 3x squared. Okay, which is normal. But then when I take the derivative of y, the derivative of y goes to 1. And then I attach a dy dx. Okay, if you were here last time, basically just know if it had a y in it and you take the derivative, you add the dy dx to that. Okay, then from there, we're doing diagonal plus diagonal. So this plus this. It really doesn't matter which one you write first. Bless you. Okay, and then remember, that's just the product rule part. Now I have to keep going through the rest of the equation. So for the minus y, what's the derivative of that?
d1.
Minus 1 dy dx. Very good. You don't have to put the 1 if you don't want to. And then the derivative of the 7 will go to a 0 because it was a constant. Okay, from there, anything that doesn't have a dy dx, you're going to push across to the other side of the equals. So this term right here, it was a plus. When I move it over, now it's a minus. So I have a negative 3x squared y on the other side. Now, out of the remaining two terms, you'll notice they both have a dy dx. So we're going to take that dy dx out to the front as a GCF. And that's going to leave me, if I pull this out, with an x cubed and a minus 1. Are we good with that? Okay, then from there, your final step is to get dy dx by itself. So if it's multiplied by this parentheses, we can just like divide to get that out of the way. So it'll be over x cubed minus 1 and over x cubed minus 1. Okay, that equation will tell you the slope at any point that you want, because that's what a derivative is. Okay, a derivative is the slope formula at whatever spot on the graph that you want. All right, let's go on to part B. Now I want the slope when y is 1. Remember that to find slope at 1, you're going to use the original equation. Rodrigo, you need a tissue?
Yes.
Look in the little black doors of that cabinet. There might be another box.
Where?
Okay, so for a point, we're going to use the original. Is there one in there? If not, then sadly, I don't have it.
Oh. Well, there's not it.
Oh, okay, sorry.
Can I go next door?
Yeah, that's fine. So my original equation was an x cubed y minus y equals 7. I'm going to take that 1 and drop it into both of my y spots. So this would be an x3 times 1 minus 1 equals 7. That's going to be x cubed minus 1 equals 7. What would my next step be to solve? How do I get rid of the minus 1? 7 plus 1 gives me 8. And then to get rid of the cube, do you take the cubic root? Yes or no? Do you plus minus on a cubic root? No. So your answer would just be 2. Now, it's not just asking me for the point, it's asking me for the slope at that point. So now that I have an x and a y, I can go back to this formula and plug those numbers in. But remember, for these questions, you really need an XY combo to be able to plug anything in, okay? So let's practice our notation that we learned last class. You're gonna write dy dx, vertical line, and then you're gonna write the ordered pair that you're plugging in because you need both numbers. So my x is a 2 and my y is a 1. And then I'm plugging into this guy right here. So it's a minus 3x squared y. Now that's going to be a minus 3 2 squared times 1. And then on bottom, it's an x cubed minus 1, so that'd be a 2 cubed minus 1. Okay, do the top of that. What will we get? So that'd be 2 squared is 4. That'd be 12, right? The times 1 won't change anything. And then on the bottom, 2 cubed is 8. Take away 1 would be 7. Okay, now moving into part C. Okay, and I want to kind of work through this a little bit quickly just so that we can move on to the new stuff. Okay, what do I need for an equation of a tangent line? Point and a slope. And notice I already have that. Here's my point, 2, 1. Here's my slope, minus 12 over 7. So we're going to write our equation of our tangent line. Y blank equals blank x blank.
Yeah.
And then I know my point is 2, 1. So that'd be a minus 2 and a minus 1. And then remember my slope goes in true to sign. So if it's a 12 over 7, I would just leave it just like that. Okay. From there, we barely touched on this last time, but on the AP test, if they have you write an equation, sometimes they'll ask you to use that to estimate the value at a decimal. And we barely covered this last time, but all that you're going to do is take whatever this decimal is, and you're going to drop it into the X spot. Okay? So if they want f of 1.9, I'm going to plug in 1.9 where my x is, and then just figure out what the y would be at that value. So it's y minus 1, negative 12 over 7, and then 1.9 minus 2. Now, they're going to pick numbers on the AP test that will make this usually pretty manageable. So what I mean by that is that you should be able to subtract this. Okay, what would 1.9 take away 2 leave you with? What decimal? Perfect. Okay, so you have this. Y minus 1, negative 12 over 7, negative 0.1. Okay, at this step, we hate a decimal fraction combo. So if I could turn this into a decimal, that would be great. Or if I could turn this into a fraction, that would be great. But we really just want one type. Will 12 over 7 go easily into a decimal form? No, but 0.1 will. That's the same as a 10. So I'm going to rewrite this as y minus 1, negative 12 over 7, negative a 10. Because you really want the same type of thing Now I can times those fractions right across the top, right across the bottom. So what will minus 12 over 7 times minus 1 over 10 give me? 12 over 7. Okay, and then last question, if that's a y minus 1, then how do I get rid of my minus 1? Plus it, and when I plus a 1 across, I want to use a compatible fraction, 70 over 70. Very good. So when I add my 1 across to cancel out that minus 1, I would do it as a whole unit fraction. And then if you really were feeling energetic, you could reduce that, but I'm just going to leave it. Remember, for the AP test, unless it's multiple choice, you're not required to reduce this. So if you're trying to match an answer, you might have to, but this would give you full credit. Okay? All right, 2 more review topics that we touched on last time. For a horizontal tangent line, do I want okay or no?
No. I don't know. I haven't been in
That's okay. So horizontal, okay, because that gives me 0. Okay, versus vertical, I want no to get an undefined slope. Okay, so if it asks you on your homework for a horizontal, you're letting the top equal 0. Vertical, you're letting the bottom equal 0. Okay, and when I say top and bottom, I mean of this dy dx. So let's start with horizontal. What was the top of the dy dx? Negative 3x squared y equals 0. And then for vertical, I'm going to let the bottom equal 0, which was an x cubed minus 1. Okay. So this is top equal to 0. This is bottom. Okay. Now let's do the bottom one first, just because it's easier. Okay, I have an x cubed minus 1 plus the 1 across. That means that I need my x cubed to be 1. And then just like last time, I'm going to take the cubic root. Hey, Marco, you seen the notes?
Yeah.
It should be on that. Oh, wait, no, it's here. Hold on. Here.
Is that all I missed today?
That's it. And then homework on math.
I mean, I said on the homework, it was pretty easy.
Perfect. Then take the cubic root. What's the cubic root of 1? 1, so x equals 1. Now, if it says to describe the points, remember, just telling an x or a y, that's good enough. So if it says describe, you would say any point where x is a 1. Okay? Now, if it says to find the point, you would need to go back and find the y that goes with that x. Okay, Rodrigo, we ready, hen? Let's try to get caught up. Yeah, you can catch up. Okay, now let's do the top one. Okay, if you have x's and y's and they have to multiply to 0, you may not remember this, but in order for 3xy to equal 0, either the x would have to be a 0 or the y would have to be 0. Okay, and that's just kind of a weird thing that, like, if 2 things times to 0, one of them has to be a 0. So that would just be your answer. Okay. Now, we know that the 3 is not the 0. So that's why it kind of narrows it down, that it has to either be x or y. So your description would be any point where your x is a 0 or your y is a 0. Okay? All right, so go ahead and turn the page. All right, can you start off for me, please, number 10. The first thing I want you to do is identify which part is going to need product rule. So which of those terms is going to require you to do product rule on it? X, Y, very good. Now, when you pick your product rule, remember, you want to include the negative in that as well. So it really should be a negative X and then a Y. So my U is a minus X, my V is a Y. Take the derivative of that product, please. What would U prime be? -1. And then V prime, the derivative of Y, would be a 1 dy dx. Okay, but then remember, when we're taking the derivative, okay, we really have to consider the whole equation. We're not just doing the product rule. So we're going to start here at the beginning. What is the derivative of y squared? 2y what? dy dx. Very good. Okay, remember, you have to have a dy dx if it had a y on it. Okay, now I get to the product rule. So I'll do this plus that. Since they both have negatives, I'm just going to make it a minus. And then I'm going to keep going through the equation. So I did the y squared. I did the product rule part. What's the derivative of the 3x part? 3. And then the derivative of 9 is 0. Okay, from here, which terms are we going to scooch across to the other side? Okay, the 1y and the 3. And remember that when those guys move over, you're going to have to change their signs. So my negative y is now a positive y. My 3 is now a minus 3. Out of the remaining 2 terms, they both have a dy dx. Remember, you're going to pull that out. So you'd have dy dx parentheses, and then a 2y minus x. Good so far to there? Okay. And then what do I do with the parentheses? Well, not this, we just undistributed it, so we want to now divide it. That's okay. All right, so that's your answer. Remember, this is the slope at any point that I want. Okay, are we okay with that? All right, parts B and C are review. So to make sure that we have plenty of time to cover the new stuff, we're going to cross those parts out and go down to part D. Okay, but for parts B and C, you should know how to find points and you should know how to write equations of tangent lines. Okay, if you need to go back over that, I'm happy to help you with that on the homework. So go down to part D. I want a horizontal slope. What am I setting equal to 0, top or bottom? Top, very good. Horizontal is top equal to 0. And then vertical will be bottom equal to 0. Okay, let's do top equal to 0 first. What's the top of my dy dx equation? So I'm going to let y minus 3 equal 0, and then I'm going to solve it. So plus 3 plus 3. Right. No, there's no 7. They're trolling. Okay, so your description would be any point where your y is a 3. Now, for your homework, let's say that it asks you to actually find the point, because it does. So I want you to adjust. What if it says find the point? Then now, me just knowing that 3, that's not enough. So where do I go to find the other half of the point if I know just the x or just the y? The derivative or the original? Original is correct. So my original equation was a y squared minus xy plus 3x equals 9. And then I know now what my y is. My y is 3. So let's plug it in. 3 squared would be 9. X times 3 would be a 3x plus 3x equals 9. And then what is going to happen when I combine the 3x and the negative 3x? They cross out. So in this case, you would say there is never going to be a point where my y is 3. So because this kind of weird thing happens, I can't actually solve for an x that goes with it. Then you would say there's no such point. So in this case, if there was a point where y was 3, I would have a horizontal spot. But because that can never happen, this equation won't ever have a 0 slope. Okay? But for your homework, you should get a value for that second part. You shouldn't have any no such points, I don't think. All right, take a look at the second part. We're setting the bottom equal to 0. So I have a 2y minus x. And we're setting that equal to 0. Okay, this part gets a little bit tricky, but I want you to just kind of stick with me. Okay, the first thing that I know is that if I only had an x or y, this would give me an answer, but I have both. So you're going to have to use a substitution into the original equation. Now, I want you to pick the easier option to solve for. Would it be easier for me to get x or y alone? X. So can you do that? So if I add my x across, I know that my x is a 2y. Is everybody good with that? Okay, now here's what I'm going to do. Everywhere that I have an x in the original equation, I'm going to switch it to a 2y. Okay? So I'm going to rewrite my equation down here. You don't have to do this if you don't think that it's necessary. Okay, but I'm going to circle the 2y and I'm going to put it here and here. Ogo, are you wondering where that came from? That's the original equation from up here at the top. You good? You sure? Okay. Yes. Oh crap. I'm sorry. We're plugging into the X's. Thank you. That's my mistake. So not that one. We'll plug it in here and here. Thank you. Yeah, that's my bad. That's my bad. So I have a y squared. And now my x is going to swap out for a 2y. And my other x is now a 2y next to the 3 equal to 9. What is 2y times y again? Multiply.
Y squared.
2y squared. Okay, and then 3 times 2y is a 6y. Now I notice that I have multiple terms that are y squared. That means I can combine them. So what is 1y squared? Take away 2y squared. Good. Okay, negative y squared plus 6y. And then you should notice at this point that this is quadratic because I have a regular y and a y squared. So we're going to bring the 9 across. That's right. Now, you should never AC chart with a negative on your front term. So to fix that, if I want to swap my y squared to a positive, I just have to change all the signs. So it'll be a positive y squared, a minus 6y, and a plus 9. Can you think of numbers that will times to 9 and add to minus 6? What types of 3 do I need to use? negative. So it'd be y minus 3 and then y minus 3 again, which means what's my only answer if the parentheses are identical? Y equals 3. Now, if it said describe the points, that would be plenty. What does it say for this question? Find the points. That means I need an x and a y. But what easy relationship do I know about x and y? X is what? 2y. So if my y is at 3, what's my x that goes with it? 2 times 3 would be 6. So your ordered pair for the point would be that my x is a 6, my y is a 3. When that combination happens, I'm going to have a vertical slope. Does that make sense? Okay, turn the page. We have one new thing to cover. So skip the next problem and go to the one that says number 12. Okay, right here. Okay, first thing I want you to do is take the derivative. Okay, so we have 2 more examples that we have to work through, but remember, they're not just like one thing, it's a few things, but we can do it and then you'll have homework time. So what rule do I need to take the derivative of this? Product rule, can you set it up for me? Your u will be what? X. And your v will be a y3. What's u prime? 1. What's v prime? 3y squared. Attach the dy dx clinger because it was originally a dy dx or a y, then I have to add that to the end. Okay, then do your diagonal. Will it still equal 27? After I take the derivative, it'll equal what? 0. So I have 1y cubed plus, and then x 3y squared dy dx. All right, from here, I actually was kind of plugged in. I just didn't quite get it all the way in. Okay, from there, who am I moving? So I have 2 pieces. I have this piece and this piece. Which one am I going to move, first or second? First, because remember, whoever doesn't have the dy dx, that's the one that you push across. So this one's going to move over here. It used to be positive, which means now it will be what? Negative. So I have a minus y cubed. You can write the 1 if you want to. And then on the other side, I'm going to just rearrange this to be a 3xy squared. But it's really the same dy dx. Now, if I had multiple terms that were staying on the left-hand side, I would GCF it out. But since I only have the one term, there's only one dy dx anyways for me to leave over there. What do I do with the 3xy squared from here? Divide. So here's your equation. So dy dx equals negative y cubed over 3xy squared. Okay. Next part of this, I'm going to do a little bit of like skipping. Do you know how to find the rest of the point? Do you remember you used the original? Okay, and I'm going to give you the answer. It should be 2, 3. Okay, for your homework, it's going to tell you the entire ordered pair anyways. So that's why you should know how to do that. Just to kind of shorten the notes a bit, I'm just going to give you the answer. 2, 3 is correct. But you should know how to do it if you don't ask me for help. Okay, we're skipping down to part D. You should know how to write the equation of a tangent line, so we're going to skip that part. What does this mean for you to do? So it's a d squared y dx squared. Do you know what that means? Do you remember? It's been a while. Yes. Okay, very good. If you didn't hear, she said that means to take the derivative again. Okay, so this is called a second derivative. Okay, and the reason why is that I want you to write dy dx is the first derivative. D squared y dx squared is the second derivative. Okay, and you should be somewhat familiar with those notations, but we really haven't done much of it. Today's kind of the first day. So this is my first derivative, and I want to take the derivative again. I'm going to give you a tip here for your homework. Okay, you want that to be as clean as possible. So look at that derivative and see if anything can cross out. Hello? Saida? That's okay. She's checking out or? Okay, got it. Thank you. Okay, bye. Bye. Saida, you get to go home. All right, so looking at your dy dx, do you notice anything that we could like make better? Yeah, I have y's in both parts of the fraction, so could I reduce those? So if I have a cubed on top and a squared on bottom, yes. When they cancel, how many extra y's will I have only? Will it stay top or bottom? Top. So I'm going to put here that I want to simplify this because I don't want to take the derivative again if it looks crazy. Have a good weekend. Okay? All right, so we simplified that by dropping the extra y off. What's up, Lachey?
It's not. But it's fine.
Are you sure? It's gonna be a little bit. Okay. All right, from here, we need to take the derivative again. Now, I want you to look at that equation. What rule is this gonna need? Here are your choices. Product rule, quotient rule, or chain rule. Good. So for part D, you're going to have to use quotient rule because your X and Y stuff are divided with each other. So quotient rule is the high and the ho thing. Okay? So the high is a negative Y. Ho is a 3X. That means that D high is what? Negative 1 what? Dy dx. Because remember, if it had a y in it, you have to keep the dy dx on the end. Okay, then for your 3x, what's the derivative? For d ho, just a 3. And then I want you to write your quotient rule. Now, you can label it either way. If you like the y double prime better, that is shorter. I'm going to write it this way just to practice that notation. Okay, but these are the same. So d squared y dx squared equals, remember it's ho d high minus high d ho. So 3x times a negative dy dx minus high d ho would be a negative y times 30. And then all of that over ho squared would be a 3x squared. Okay. From here, your homework is going to ask you to take this second derivative and plug in your 2, 3. So if you look right here, it says to find the second derivative, we did it. Now we're gonna do it at that point. So there's a crucial step that you have to recognize before you plug in. When I plug in, I need two things. I need the x and the y, 2, 3, and I need to know what dy dx is at that number. Okay, and so if you think about that, that should make sense because when I'm looking at this equation, I know what to put for x. It was a 2, right? I think. Yep. Okay, and I know what to put for y. My y is a 3. But this dy dx spot, I have to have an answer to be able to plug that in. So where will I get dy dx? I'll do the 2, 3 in the original derivative that I already had to know what that number is. Okay, so let's find that first, then we'll plug into our equation. So write dy dx, vertical line 2, 3 equals. And then I can plug into either one of these, but why would I use the worst one if I don't have to? So I'm going to use this one. So it's a negative y over a 3x. So it'd be a negative 3 over a 3 times 2. And then from there, that'd be negative 3 over 6, which is negative a half. So now I have every item that I need to plug into. I know my x is at 2. I know my y is at 3. And I know I'm going to put a half in the dy dx spot. So now we can plug into this. So do d squared y dx squared. Vertical line 2, 3 equals. And then we're going to plug in all of this information into my ho d high minus high d ho over ho squared. Okay? So let's do it. 3 times x, what's my x? X is a 2, so that'd be a 6. What is my dy dx value? It's negative a half, but if I also have a negative in here, what will it be? Positive a half. Minus. What is my y? 3, so it'd be minus a negative 3 times 3. And then if you want, you could cross those negatives out, which I think I'm going to do. And then on the bottom, I want a 3x squared. My x is a 2, so what's 3 times 2 here? That'd be 6, and then 6 squared. Okay, for my first term, half of 6 is 3. We're going to add that to a 9. 3 times 9 is 12. 6 squared is 36. So that would go to a third. Okay. Questions on that? So you take the derivative once, take the derivative a second time, and then when you plug in, you have to have an answer for dy dx to use with the x and the y. All right, we're just going to do maybe one more of those, and then we're going to switch to homework. So turn for me, please, to number 13 on the next page. All right, take the derivative for me. Just next question. Okay, will you need any special like product rule, quotient rule type things? No. So 2x squared, what will that go to? 4. Okay, 4x. Then my y4 will go to a what? dy dx equal to 0. Who are we going to push across? Okay, so now it'll be a minus 4x, right? And then I'll divide the other stuff across. Now remember, at this step, if anything can cross out, I want to do it because I want my first derivative to be as clean as possible so that I don't have like extra stuff going on. So what could I cross out from the second derivative to make my life easier down the road? The 4s. So I'm going to put dy dx is really a negative x over a y cubed. And that's the version of the first derivative that I'm now going to take the second derivative with. Okay? So let's do it. Skip down to part D where we're asked to take the derivative again. What rule are we going to need to take the derivative again? Quotient rule. Very good. So I'm going to put take derivative again. And then I'm going to put needs quotient rule. So my high is going to be a minus x. And ho is going to be y to the 3. What's d high? -1. What's d ho? 3y squared dy dx. Okay, then from there, I'm going to write my second derivative. Remember, the order matters for quotient rule. It's ho d high minus high d ho. Okay, if you want to write it as y double prime, that's okay. Because remember, that's the exact same thing as this notation. So ho d high would be y cubed times a -1 minus a negative x times a 3y squared dy dx. And then on the bottom, we have a ho cubed or ho squared, which would be y cubed squared. Okay. From here, I'm just going to tell you the point again so that you don't have to go back and find it because that's what your homework's going to do. It's going to tell you to plug in a point. Your point is 2, 1. Okay, and I could make you find it. You could do it. The math isn't hard on it. Okay, but your homework is going to tell you the whole point to begin with. What extra ingredient do I need before I can plug in here? I need to know the dy dx or the slope, correct? So I'm going to find dy dx at that point first before I plug in. Because I have to know the answer for the first derivative to be able to plug in for the second derivative. Now remember, I have 2 versions. I can pick whichever one I want, but I'm going to pick the easier one. So do you remember that it was a negative x over y cubed? So now it's a -2 over 1 cubed. What will I use for my dy dx? -2. And now I have all my ingredients that I'm ready to plug in here. Okay, let's do it. So it's going to be d squared y dx squared, vertical line, 2, 1. That's the point that I'm plugging in. And I have all 3 ingredients, an x, a y, and a slope value to plug in. So let's go one term at a time. What is my y digit? 1, and what's 1 cubed? 1 times -1 minus. Okay, what's my original x value? But I'm plugging in a -2 because it's a minus x, right? Okay, then I want a 3y squared, but what's my y? So that's really just going to be a 3 times 1. And then what's my dy dx number? -2. So on the top, this would be a -1 And then -2 times 3 is -6. That would then be a +12. But then, hold on. So 2 of these are going to cross out. So it'll come out to be a -12. So I took these 2 negatives and just canceled them. So I didn't have so many. Then what is -1 minus 12 more? 13. And then is that my answer? Don't forget whole squared, right? So on the bottom, I want my y value, which is what? 1 cubed is still 1, and then squared is still 1. So -13 will be your final answer because it's just over a 1 anyways. Okay? All right. We have 30 minutes. Okay, but when you open up your homework, I want you to do the second derivatives first. Okay, so they're the last couple of questions. Do those first, and then we'll go back and work on some of the first questions later. Okay, but the second derivatives take a while. You're surrounded by your friends that can help you and me. Okay? Let's see what's up. So do second derivatives first. Do you want paper? You want paper back there? Yes, I'll do it right now. Go on paper. Okay. Okay. Roberto wants some little paper. Michael. Okay, Mauricio, Rodrigo. What are we doing?
Good.
Okay, Lachey.
Oh, so it was my fault because I tried to
Yeah. You just need me to take the late films out?
Yes.
Got it. I'll do it right now.
Okay. And then the test review.
Mm-hmm. The test review?
Yeah.
We just did it. Were you absent? Let me see if I have yours to pass back. It could be my mistake. Jacob, Raku. Melvin, this is what it looks like. Here, look at hers. That's what it should look like. And then remember we did like a few graphs.
Yeah.
So just look at your stuff.
Okay.
Maybe you might have it, but I'll give you a blank copy just in
Okay.
case. And then just turn it in next week.
All right, that's fine.
If you can't find it or get it in your stuff.
And then you said the questions I could probably do next week when I turn this in. We'll probably do the test review, right? Or no?
Test review is that
Or no.
corrections?
Correct.
Yes, that's fine.
Okay. Awesome.
Yes, come in with your buddy,
Yeah.
you know? Okay.
Yeah, I think it was 3 and 4.
It's okay. I'll be able to find them.
All right, thank you so much.
You don't